All right, hi everybody. Today we are going to be talking about trigonometric ratios. So if you have this piece of paper printed out that I attached, cool. If you don't, you'll still be able to follow along, okay? But if you're able to print this out and you might want to take some notes on it, that'd be great. Another couple of things you're going to need while you watch this video. You're going to want to have another sheet of paper. Graph paper would be great, or if you want to just use the back side of this, that's fine as well. And you're going to need obviously something to write with, but you're going to need a ruler of some kind. Now, if you have a ruler that has a centimeter side in addition to an inches side, that's going to be even better. But again, just do the best you can, and if you don't have all this stuff, try to just watch and listen and follow along, and you'll probably be okay. But the best thing you could possibly do is journey along with me as I do some activities and you do them with me. Now, where are we journeying to? Well, I said the topic of this video is trigonometric ratios, trig ratios as we call them. That means we are doing trigonometry today, trigonometry. So you might have heard that word before. It might sound scary to you, but what I want you to know about trigonometry is you already know how to do some trigonometry. You're already a trigonometer of sorts, because trigonometry is just the part of math that has to do with triangle measurement. So we call it trigonometry because it's measuring triangle stuff. So haven't we already done triangle measurement stuff like a squared plus b squared equals c squared? Yeah, so the Pythagorean theorem is part of trigonometry, and even stuff like knowing that the three angles of a triangle add up to 180 degrees is part of trigonometry as well. Today we're just going to go a little bit deeper into trigonometry. So I'm going to switch over and we're going to do a little activity together. So get your papers and your pencils and your rulers all ready to go so you can follow along with me right now. Here we go. The first thing I would like you to do is on a piece of paper, again, graph paper, awesome. If not, you'll survive. Okay, and I just want you to make, to the best of your ability, okay, make a horizontal line. So I have an advantage because I have this graph paper, but I'm still going to try to use a ruler to make it nice and straight, and I'll try to do it on the grid. All you need to try to do is make a nice, good, straight horizontal line. Okay, good. Now that we've got a horizontal line, I want you to just create an acute angle starting from somewhere to the left side of this line. So I'm going to start right here, and I'm going to create an acute angle with my ruler, and then I'm just going to go like that. Your acute angle can be wider than mine or narrower than mine. It can be, don't make it a right angle. Make it an acute angle. But we want to have an acute angle to work with. And then we're going to take this acute angle, and I'm going to turn this acute angle into 3 different right triangles. How am I going to do that? I actually can do this without a ruler because I have my grid paper here. I'm going to draw one upright line. I'm going to draw another upright line. And then I'm going to make an even bigger triangle by going like that. Okay, again, you can space these out differently if you want. Your drawing doesn't have to look exactly like mine. It just has to be an acute angle right here and 3 triangles made from that acute angle. So I'm going to mark this acute angle. I'm going to call it angle A because I like it. And what we're going to now do is we're going to do some physical trigonometry where I actually measure some different parts of these angles. So, not these angles. I'm going to measure the triangles, actually. This is where having the centimeter side of your ruler is going to come in really handy. We're actually going to use the little millimeter marks, the little marks in between each centimeter. So where the 1 is, that's 1 centimeter, which is how many millimeters? 10. So I'm going to measure several things here. I'm going to measure this hypotenuse right here, and this leg right here, and this other leg right here. So I guess I might as well just call that A, B, C. right? Like a squared plus b squared equals c squared. I could measure those and make sure that I drew my triangle correctly and that this is a right triangle by seeing if a squared plus b squared equals c squared, but that's actually not what we're going to do today. What we're going to do today is we're going to find the measurement of a and b and c, and then we're going to find the measurement of, I don't know, I guess I could call it d, e, f. And then guess what we're going to do? We're going to do that same thing for the larger triangle. So I did A, B, C, D, E, F, G, H, J. I'm going to skip I because I kind of looks like a 1 sometimes. Plus I just like the letter J. Okay, what I'm going to do is I'm going to start measuring A and B and C, D, E, F, G, H, I, and I'm going to try to do it all in millimeters. And I want you to do the same thing with what you drew, except your numbers will just be different from mine, and that's okay. Just to give you an example, you can watch me do this, or you can just let me play in the background while you measure yours, or you can pause this video, etc., etc. So for me, that first leg is 70 millimeters. B is, and here's where you're going to have to just estimate a little sometimes. I'm going to say that's about 20. And then C is crooked. It's probably some irrational number like most hypotenuses are. That to me looks like about 73. I could be a millimeter or so off, and that's going to be okay for the purposes of this lesson. So don't stress about it too much. Okay, now I'm going to do D, and that looks like 102. Again, right now you don't have to even be watching my measurements. You can just be taking your own measurements of what you drew. And then once we've all got all of our measurements, I want to tell you about what you're going to do after that. But first we got to get all this data. We got to get all these numbers. All right, G, this big old bottom leg on here, it looks like 166 millimeters. H is 45 millimeters. And finally, my last measurement, this big hypotenuse, J, is about 171 millimeters. Okay, so I've got, let's see, 9 different numbers here, right? 3, 3, and 3. 3 blue numbers, 3 purple numbers, and 3 green numbers here, if you squint. And you could, you know, pause this video and find issues with my measurements and tell me that I didn't measure accurately, and that's fine. But for the purposes of what we're going to do right now, I think it'll work okay. What I want to do right now is I want to make a table of some ratios. And this table is going to be three by 3. Okay, so we're going to do some ratios for the smallest triangle. We're going to do some ratios for the bigger triangle, the purple measurements, and then we're going to do some ratios for the biggest triangle, the green measurements. Now, since all 3 triangles were based on that same acute angle, and they're all right triangles, would you agree that all 3 triangles are what we would call similar? Or what we would call proportional? Theoretically, they should be. Now, our drawing ability means that our measurements might not be perfect, but the ratios should be the same, correct? Okay, so for the little triangle, I'm going to do first B over C. So for you, I want you to make a ratio of B over C, whatever that is for you. For me, it's 20 over 73. 20 over 73. Okay, then we're going to do that same ratio, but do it for the next biggest triangle. So what would that be? That would be like, instead of this over this, it would be E over F, right? Hopefully that makes sense to you. So for me, that's 29 over 105. Again, your numbers are probably totally different. Wait a second, I was supposed to put that here. Sorry, E over F equals 29 over 105. And then for the green triangle, that would be H over J, right? The upright leg over the hypotenuse, H over J. And that would be 45 over 171. Now what I want you to do is punch those ratios into your calculator, do the division, and tell me, did we draw roughly proportional triangles? So 20 divided by 73. Again, your numbers are going to be different. That's totally fine. I got about 0.27. For my second one, 29 divided by 105. I got, oh my goodness, about 2.7, but I guess we have to round that to 0.28, but pretty dang close. Pretty dang close. For my third one, 45 divided by 171. 0.263. Okay, so they were all within a 100th of a millimeter of each other. So that's pretty dang close. Now, that's not surprising because these triangles are just bigger and smaller versions of each other. They're similar, they're proportional, they're what we would call dilations of each other. And the reason that they're all dilations of each other is because we use the same angle to start them all off. And wouldn't it make sense that you could make a triangle that was like 100 miles long if it was based on that same angle? Wouldn't the ratios be the same? Theoretically, yes. Okay, so what I want you to do now is I want you to try to do the same thing for other ratios in these triangles. So instead of B over C, now I'm going to do A over C here. And then my third one is going to be B over A. So that means for this triangle, instead of A over C, it's going to be D over F. And then this one's going to be, instead of A over C, G over J. And then for this one, B over A. So it's the two legs. It's the upright leg over the horizontal leg. Upright leg, horizontal leg. So E over D. And then upright leg over horizontal leg. So that's H over G. I think I've got a leaky pen here. I've got ink all over myself already. But that's okay. Math gets dirty sometimes. So take a minute, calculate all these ratios. I'm going to do mine while you do yours. And at the end, we'll see how good we were at drawing ratios and drawing scale triangles. All right, here I go. A over C is 70 over 73. B over A is 20 over 70. D over F is 102 over 105. E over D is 29 over 102. For my big triangle in green, G over J, that's 166 over 171. And then H over G would be 45 over 166. Now I'm just going to get my calculator and do a little math. It's a pretty boring video right now, but you'll see the magic in a few minutes. Okay, now 102 over 105. Oops. Oh, look at that. Good job, me. 29 over 102. Oops, 29 is 0.28. And finally, my little triangle ratios, 70 over 73 is 0.96. and then 20 over 70 is about 0.29. So this column, and this column, the values came out basically the same, more or less, with a little bit of human error in there. And again, should that be shocking? Should that be surprising? No. If I use the same angle, then any right triangle should have those same proportions. Well, what we do in math, in trigonometry, is we take these ratios and we give them names. Each of these ratios has a name, and these are called the three trig ratios. And they have names, and the name of those three trig ratios are, this trig ratio is called the sine ratio, S-I-N-E. This trig ratio here is called the cosine, C-O-S-I-N-E, like sine, but cosine. And then the third one is something totally different, and it is called the tangent ratio. So we have the sine ratio, the cosine ratio, and the tangent ratio. And these are what we call the three trig ratios for any right triangle. And the beauty of this is, if you know how many degrees your angle is, it doesn't matter how big or small your triangle is, you should know what the sine ratio for that angle comes out to, what the cosine ratio for that angle comes out to, and what the tangent ratio for that angle comes out to. And human beings over the centuries have basically taken every possible number that you could put there, right? Every possible angle measurement that you could put right here, whether it's a 1 degree angle, or a 2 degree angle, or a 3.72 degree angle, or a 45 degree angle, or a 46 degree angle, we now have in our human knowledge databanks, because of people putting in the time and effort, we have these numbers. These numbers are known. Like, you could find a table of them. You could search sine ratio table or cosine ratio table, and you could Google it, and you could find what the sine ratio for a 31.5 degree angle is, or you could find what the tangent ratio for a 89.2 degree angle is. These are known. And how are they known? Because people decided to do the trigonometry. Okay, now, that's cool. You might be wondering, what's the point? And we'll get to the point, and I'll tell you why this is helpful and valuable and important later. But for now, let's really hammer home, what are our three trigonometric ratios? Our three trigonometric ratios are called sine, cosine, and tangent. We abbreviate that SIN for sine, COS for cosine, and TAN for tangent. So now, if you go to your scientific calculator and you were always wondering, why is there a button that says sin on it? Like, am I allowed, if I touch that button, am I doing something wrong? Am I going to be in trouble? Have I committed some kind of an error if I press the sin button? Well, it's not a sin button. Doesn't mean that you've committed some kind of ethical or moral folly. That's a sine button and a cosine button and a tangent button. These are trig buttons. So you know how I said you could find sine ratios, cosine ratios, and tangent ratios for any number? I could go sine of 30 degrees, and I could punch it in, and people already know that that's a 0.5 ratio or a 1:2 ratio. And I could do the cosine of 30 degrees, and that one comes out to be a little bit of a weirder ratio, etc., etc., etc. So what is the sine ratio, the cosine ratio, and the tangent ratio? For angle A, right, angle A, the sine ratio is the measurement of the opposite side divided by the measurement of the hypotenuse. So sine ratio is always opposite over hypotenuse, which is what we did on this. You could go back and look at your notes. It was B over C, right? Opposite of that angle over the hypotenuse. That's sine. What is cosine? Instead of going across to the opposite leg, we're going to use what we call the adjacent leg. What does adjacent mean? Adjacent means next to. So I could say that my red pen is adjacent to my green pen right now. Why? Because they're next to each other. They're adjacent to each other. So what side of the triangle is adjacent to angle A? Well, the hypotenuse is adjacent to it, and leg B is adjacent to it. So when I say side adjacent to angle A, I really mean the leg that's adjacent to angle A, because technically the hypotenuse is also adjacent, but the hypotenuse counts as the hypotenuse, not as the adjacent side. Okay, that's cosine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. What's tangent? Tangent is opposite over adjacent. Where's opposite and adjacent? Well, from angle A, from that perspective right here, opposite A, right, over adjacent B, so this would be A over B. Sine of angle A would be opposite over hypotenuse, A over C. Cosine of angle A would be adjacent over hypotenuse, B over C. Whew! It's going to take you a while to memorize this. And in order to memorize this, I've given you a little helpful memory device. And it's a memory device that math teachers over the centuries have used to help students remember the 3 trig ratios. It's called Sohcahtoa. Pause this video and say Sohcahtoa. Okay, now unpause and say it again with me. Sohcahtoa. Sohcahtoa. What is Sohcahtoa? Sohcahtoa is one word that summarizes all 3 trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, these sine, cosine, and tangent ratios were the sine, cosine, and tangent ratios of angle A. But that's not the only acute angle in this triangle. Isn't there also another acute angle right here? Angle B? So for angle B, can you pause this video and tell me what the sine ratio, cosine, and tangent ratio would be in terms of A, B, and C like we did here? All right. The sine of B, remember sine is opposite over hypotenuse. So what's opposite B? Opposite B is little b. What's H? Hypotenuse, so that's C. Cosine of B, what's cosine? Adjacent over hypotenuse. So what's adjacent to angle B? A. And then what's the hypotenuse? C. And then what's tangent? Tangent is opposite leg over adjacent leg. So opposite leg over adjacent leg, that's the 3 trig ratios from the perspective of angle B and from the perspective of angle A. Let's just do a little bit more practice, and then I think you'll have your trig ratios really down, and you'll be working on memorizing Sohcahtoa and what it means and practicing it until you get real good at it. All right, so the length of the hypotenuse is what? 17. The length of the side opposite angle P is 15. The length of the side adjacent to angle P, here's angle P, right? Adjacent to that is 8. So opposite 15, adjacent 8, hypotenuse 17. So the sine of angle P, opposite over adjacent would be opposite over hypotenuse would be 15 over 17. And this spot is here if you want to, punch that into your calculator and make it into a decimal. You could do that. Cosine, what's cosine? Adjacent over hypotenuse. That's 8 over 17, right? Adjacent over hypotenuse, 8 over 17. Then what would the tangent of P be? Well, what's tangent? Toa. Opposite over adjacent. Tangent, opposite, adjacent. Opposite over adjacent. So that would be 15 over 8. That's how you find trig ratios. It's as easy as that. You got 3 numbers to choose from, and you just got to put the right numbers in the right spots. So I want you to go ahead and look at this example right here and see if you can come up with the correct ratios for this triangle from the perspective of angle X and from the perspective of angle Y. Give that a try. All right, here's the answers. The sine ratio for angle X would be opposite over hypotenuse, so that'd be 16 over 20. Oh, if you can reduce it, you probably should. So what am I going to do with this? I'm going to make it 4/5. Cosine of X would be adjacent over hypotenuse. That's 12 over 20. If you can reduce that, you probably should. So that's 3/5. And then tangent of X is opposite over adjacent, 16 over 12. That would be 4/3. Okay, what about angle Y? From the perspective of angle Y, now 16 is an opposite, 16 is adjacent, 12 is opposite. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And what do you notice about this? There's some kind of interesting symmetry-ness to how some of these work with each other, which is kind of makes sense if you think about it. All right, if you were able to get all of those correct, then you are good to go. Thanks for watching. Thanks for listening. Thanks for being a trigonometer.